Hi guys, today we're going to continue with trigonometry. In our last lesson, we talked about the tangent ratio, and we talked about the fact that the tangent of an angle is equal to the opposite leg over the adjacent leg. Today we're going to focus on our sine and cosine ratios. Our sine ratio is the sine of the angle, and again, that's whatever angle they give you, is equal to the leg opposite that angle over the hypotenuse. So once again, sine is going to be the sine of the angle is equal to the opposite over the hypotenuse. Cosine of the angle is going to be the leg adjacent to that angle over the hypotenuse. So again, the cosine of the angle is equal to the adjacent leg over the hypotenuse. And just remember something, when they have that A in that formula, that is whatever angle they give you there. So that could be any angle you see there. Whatever angle that is given to you, that's the angle. Now, right here you see this little acronym. And that word is actually the word SOHCAHTOA. And it's an acronym because we use it to help us remember which trigonometric ratios go with which sides. So, for example, the first one, okay, you see sine. That S there stands for sine. And our sine ratio is our opposite over our hypotenuse. That's what that stands for. The sine of an angle is equal to the opposite over the hypotenuse. The next letter, C, stands for cosine. And that is when we have our adjacent over our hypotenuse. So the cosine of an angle is equal to the adjacent over the hypotenuse. And the last one at the end there, that T stands for tangent. And that is our opposite over our adjacent. So the tangent of an angle is equal to the opposite over the adjacent. We pronounce that word SOHCAHTOA. And again, that's an acronym to help us to remember our trigonometric ratios. All right, let's take a look at this next part here. It says, write each trigonometric ratio as a fraction and as a decimal round to the nearest hundredth. Okay, so for this first one, we're going to look at A. A is the angle they're telling us to look at. So from A, we want to use cosine. Cosine is adjacent and hypotenuse. So we have three sides here. We have to decide which one of those is our adjacent and, of course, which one is our hypotenuse. Now, we have the right angle. The side across from the right angle is always our hypotenuse. That's always the hypotenuse no matter what. That means that the 7 is opposite. The 7 is across. So the 24 must be our adjacent. So we want to have the adjacent and the hypotenuse for that ratio. So we're going to set that up. The cosine of angle A is equal to 24, the adjacent over the hypotenuse of 25. And then we could divide that 24 divided by 25 in our calculator and just get a decimal, which would be 0.96. And again, it's said as a decimal round to the nearest hundredth. For the next one, we want to focus on a different angle. This one says B. So B is a different angle this time. Tangent of B. So from B, let's talk about our sides. From B, the 24 over here, that's now the opposite. The hypotenuse is always the hypotenuse, right? That's going to always stay the same. And we also see here that we have our adjacent is the one that's going to be next to that angle. So that is 7. Okay, so again, it's all about angle B this time, the opposite and the adjacent. So we want to put 24, the opposite, over the adjacent of 7. Okay? And finally, we have the last one, the sine of B. So this time we want to use the sine ratio. The sine ratio is opposite over hypotenuse there. So we want to do from B, where's the opposite? The opposite is the 24. And of course, the hypotenuse is 25. And if we go back and get some decimals for this one here, again, 24 divided by 7 would be 3.43. And 24 divided by 25 is 0.96. And yes, those two are the same answer because the cosine of angle A and the sine of angle B will be the same measurement there. The sine and the cosine are like inverses of each other. So, remember something, the hypotenuse is never the adjacent leg. The side across from the right angle is always the hypotenuse. Okay? Let's use these ratios now to solve for some missing side measurements. So let's take a look. Remember, it's all about the angle that's given to you. So they gave you the 67. From 67, what do you have? You have an opposite, which is x, and you have, here's the right angle, you also have the side across from the right angle. You have a hypotenuse. So we have an O and an H. If we take a look here, we're looking for the one that has O and H. It's our sine. Sine is the one that's going to have the opposite and the hypotenuse in it. So we're going to use sine. The sine of the angle is equal to the opposite over the hypotenuse. So we're going to say that the sine of the angle 67 is equal to the opposite x over the hypotenuse of 120. Okay, so just like we did before with our tangent lesson, we're going to our calculator. We're going to use the sine button this time. So the sine of 67 is equal to 0.9205. Again, we're going to round that off to 4 decimal places. 0.9205. I told you to put that over 1. And now we're set up in a situation where we can actually cross multiply there. We're going to cross multiply. So, all right, we've got this times this. So right here, we're going to put 0.9205 times 120, and we end up with 110.5. You can see that in our calculator there, 110.5. Oh, it looks like the bottom of my calculator is all wet. Okay, so let's keep going. So we're going to cross multiply, and we end up, like we said, with x equaling 110.5. Again, these are side lengths, so we are rounding off to the nearest tenth of there. Okay, so let's continue on the next one. All right, and this next problem here, I already set that up for you. From the angle, there is no opposite there. There's no opposite. We have the adjacent, and we also have the side across from the 90. We have our hypotenuse there. So the cosine of the angle is equal to adjacent over hypotenuse. Again, A and H, if you look over here, that is going to be our cosine ratio. So the cosine of the angle is adjacent over the hypotenuse. So the cosine of 67 is equal to y, the adjacent, over the hypotenuse of 120. We're going to find the cosine of 67 in our calculator. Head over 1. And then we have our y over 120, so we are going to cross multiply. And when we do that, we find out that that missing side is 46.9. Okay, that's our side value y. All right, let's continue down here. Now, take a look at this one. This one looks confusing. All right, if you take a look at this, how do we know what to do first? From my angle, I have 2 missing sides. I have an opposite over here. Of course, we know the 1,000 is across from the 90, so that is our hypotenuse. But this side right here, that is our adjacent to that 28. Oh boy, I got all 3. So how do I decide which one to use? So here's my advice. Cover up one variable. Cover up one variable and solve for each side separately. Solve for each side separately. Okay? That's what we want to do. So I'm going to cover one up. I'm going to cover up the y. I don't even want to look at that right now. I'm just going to focus on the x. Okay, covering that up, not looking at it. So if I don't look at that, I have an O and an H. Of course, that would tell me I want to use sine right there. So I'm going to set it up. Sine of the angle, opposite over hypotenuse. So the sine of 28, that's my angle, is equal to the opposite, which is x for us. Our O is x this time, right? It's our opposite over the 1,000. Okay, over the 1,000. All right, we're going to put sine 28 in our calculator. We get 0.4695, and we're going to put that over 1. Okay, and we cross multiply that, and our x value there works out to be 469.5. Okay, so that is the length of this side right here. Okay? All right, now we've got to solve for the other side. All right, we're going to cover that one up this time. This time we have an A and an H, which means I'm going to use cosine. So the cosine of the angle is equal to the A over the H. So the cosine of 28 is equal to the A, the adjacent is y, the hypotenuse is 1,000. Cosine of 28 in our calculator would be 0.8829. Again, I told you to put it over 1. And we're going to cross multiply there. And when we do that, our y works out to be 882.9, and that is our other missing side. So again, the secret to doing problems like that is to simply cover up one variable, okay, and solve for each side separately there, okay? I have another one of those problems worked out for you right over here, okay? This is a separate problem right here, okay? If you take a look from the 25, you have the opposite, you have the adjacent, right, the one across, and then of course 20 is the hypotenuse. So once again, we want to cover up a variable. I'm just going to cover that one up right now. I want to look at that. So from the 25, opposite hypotenuse, that's going to be sine. Sine of the angle is equal to the opposite over the hypotenuse. We plug in sine 25. The A is the opposite. The hypotenuse is 20. right? We get sine 25 in our calculator, and then we can cross multiply, and when we do that, we get 8.5 for that side right there, that A side. Then we want to cover that up. We don't want to look at that side now. We want to just cover that one up. I'm just going to cover that up with my highlighter here, and I'm going to focus on that. I have an A and an H this time. So A and the H, that's cosine. So the cosine of the angle is the adjacent over the hypotenuse. Now remember, our A is B, that's our B there, and our H, our hypotenuse, is 20. So cosine of 25 is the B over 20. We get the cosine of 25 in our calculator. We set it up, we're able to cross multiply, and we end up with that missing side of B as 18.1. Okay, let's go to the next page. Let's continue with these and go on to the next page. Okay, so over here on our next page, up at the top, it's asking us to find a specific side. Okay, it's asking us to find there a specific side. So again, we're going to find DF. It's all about the angle that is given to you. So the angle given to you is the 51. Across from the 51 is 17. And of course, the side across from the right angle there is our x. So we have an opposite and we have a hypotenuse. So remember in our SOHCAHTOA, right here, sine is the opposite and the hypotenuse. So we're going to set it up. The sine of the angle, opposite over hypotenuse. Sine of 51 equals 17, the opposite, over the hypotenuse of x. Okay, so in our calculator, we need to do sine of 51, 0.7771. Again, we're rounding that number off to the 4th decimal place. And we're going to need to cross multiply there. And when we do that, this is what we get. Okay, looks a little different this time. But we want to get that x by itself. So just like in normal algebra, we've got to move that over to the other side. And the way we do that is by dividing. So we're going to divide both sides by 0.771. And when we do that, we end up with our x value equaling 21.9. Okay. We have another one like that next to it here. I've set that up for you. Now take a look at the angle they give you. You have an opposite. You have an adjacent. There is nothing on the hypotenuse side. If you look at the one that doesn't have an h in it, it's tangent. When you have no hypotenuse, you always use tangent. There's no hypotenuse there. So we're going to use the tangent ratio. Tangent of the angle is equal to the opposite over the adjacent. So we set it up. Tangent of 18 equals the opposite 12 over the adjacent of x. Put the tangent of 18 in your calculator. Just remember to use the right key on your calculator. We are using our tangent button here, right, to plug that in to get those numbers. Okay, cross multiply just like we normally would. And once again, you see that right here, we end up with 0.349x equal to 12. We've got to get rid of that 0.3249 and move that to the other side. So we have to divide both sides by that number. And when we do that, we get 36.9 for that missing side, BC. All right, let's move down to the next part where they're asking us to find angle measures. Okay, it says, round angle measure to the nearest whole degree if necessary. All right, let's take a look at the first one. You have no angle measures. However, they gave you an x and a y. So we're going to use those. Now, which one you want to use? It's really up to you. You can use either one you want. Okay, once again, 2 variables, cover one of the variables up. In this case, I'm just going to use the x. I'm going to pretend that that y is not even there. So from the x, what sides do you have? Well, let's see. I have a hypotenuse. The 10 is my hypotenuse. And I have this side right here. I don't have an opposite. There's nothing on that opposite side at all. So that means this has to be the adjacent. So if we take a look, right here, adjacent and hypotenuse, that's our cosine. So the cosine of the angle is equal to the adjacent over the hypotenuse. So we're going to say the cosine of x is equal to 5 over 10. So what do you do now? Well, we could get 5 divided by 10 in our calculator. We can do that. And that would be 0.5. So we have the cosine of x is 0.5. Well, we need to move that cosine over here. Well, and if you think about it in algebra, we typically divide something on both sides. So it's kind of like dividing by cosine on both sides, but that's awkward. In our previous lesson, I reminded you that when you have 1 over x, you can always rewrite 1 over x as x to the negative 1. That can move up top with a negative exponent. We're going to do the same thing here. That cosine is going to move up top. So that cancels out over here, and x is going to move up top as cosine to the negative 1 of that 0.5. So now remember how to do that in your calculator. Right here, we want to get the -1. So we have to hit our second cosine. All right, so we're going to hit second first, okay, and then cosine. And that's going to give us that cosine to the -1 there. Second cosine. All right, and then I can put in the 0. Wrong number. Second cosine, it was 0.5. All right, that's what I got to put in. Second cosine, 0.5, and I get 60 there. Okay, 60 is the angle that I get. So that x is equal to 60 degrees there. Works out to be 60. Okay, so now we want to continue here, and if you take a look, it also asks us to find y. We found this angle is x. Now, some of you probably already know the answer right now. Again, this is a degree value. We want to round off to all whole numbers, so we got 60 for that. Now, if we take the 90 we have, the 60 we have, and that missing y, we know that angles of a triangle add to 180. So we have to add them together and then subtract that 150 from both sides in order to figure out what that y degree value is, which most of you already knew was going to be 30 degrees there. Okay, let's take a look at the next one. And the next one here, you have, let's see, from the angle, we have an opposite and we have a hypotenuse. So, opposite hypotenuse, the O and the H is sine. So from that, the sine of our angle is equal to the opposite over the hypotenuse. All right, so the sine of x. Again, ignore your other variable. We don't need that right now. Just focus on one of them. So from that angle, opposite hypotenuse, right? So opposite is 75 over the hypotenuse of 100. We can divide that out and get the decimal, 0.75, right? But again, we got to get that x by itself. So we have to move that sign over. And I told you when you move that over, that's going to become sine to the -1. So our problem is now x equals sine to the -1 of that 0.75. Or we talked about in our previous lesson how we really don't even have to divide this. We could have this written as sine to the -1 of that 75 over 100. Our calculator will allow us to do that. Watch this. Second sine of 75 divided by 100. Instead of getting that decimal, it'll also allow me to do it. And you see, I still get that answer of, again, that's a degree value, so to round that off, 49 degrees. Whole degrees there. So either way, you can put it in either way, and you will get that same exact answer of 49. Now, we still have to solve for y, and so we have to take what angles we have. Remember, we already have 49 for this one, so we have to add the 90 and the 49 and the y, set them equal to 180, and you find out that 41 is that missing value there that we have for our y degree value. Okay, one more problem, pretty straightforward. In this case, we have an opposite and we have a hypotenuse there. So opposite hypotenuse, remember, is sine. So that's going to be the sine of the angle is equal to opposite over hypotenuse, sine of n. N is our angle, equals 22 opposite over 40 hypotenuse. Okay, we got to bring that sign over because we're looking for an angle measure now. And that is going to be sine to the -1 of that 22 over 40. We're moving the sign over, that becomes sine to the -1 of that number, and we can put that right into our calculator the way that it is there, and we will get 33 degrees. If you have any questions on any of this, remember to go back, rewatch it again, and look at the examples one more time. Okay? Have a great day. Bye.